So today I am excited to discuss with you CAMeL Tools, which is an open source Python toolkit for Arabic NLP. And this is episode number 16 in our Arabic NLP series. This toolkit is a comprehensive solution that's aimed at tackling the unique linguistic challenges for Arabic. So it ranges from orthographic ambiguities to dialectical variations, and we are going to explore many of their features and applications in various Arabic NLP tasks. So you can refer to this paper because I have made like the presentation from this paper, which is give you a discussion and details about all the tools and everything you can do with this toolkit. And you can visit their GitHub to know more about CAMeL Lab and CAMeL Tools. Okay, we are going to see some of the hands-on on this topic and see some of the preprocessing utilities that exist in this toolkit. So let's start by discussing why CAMeL Tools. So as you know, Arabic NLP faces a lot of challenges that I have discussed in previous videos. One of them is what we call it orthographic ambiguity, where the Arabic scripts often omits diacritics, creating multiple interpretations for the same word. Then we have what we call the morphological richness, where Arabic verbs and nouns have thousands of forms due to the gender, number, and tense combinations, right? And also we have the dialectal variations, which add another layer of complexity, as spoken Arabic varies greatly from MSA or Modern Standard Arabic, and this is across all the regions. And also we have what we call it the orthographic noise, which especially happens in informal or digital communication, where we have the misspellings, okay, which is common. So CAMeL Tools was created to address these challenges head on by providing a unified and flexible and modular toolkit that allows researchers and developers to analyze and process Arabic text. Okay, so here are some of the key features of CAMeL Tools. So we have different of applications in CAMeL Tools. One of them, and the one that we are going to discuss in this video, and the other tasks or application, we are going to see them next videos. Okay, so the preprocessing utilities is used to clean and normalize Arabic text, and this is include what we call it transliteration and orthographic normalization. Also, we have the morphological modeling, and it includes like enables the analysis, the generation, and the reinflection of the words. We have also the dialect identification, which is a system capable of recognizing MSA and different, or to be specific, 25 Arabic dialects. We have also named entity recognition and sentiment analysis, and all together make these features form the toolkit of CAMeL Tools. Okay, so starting by pre-processing, which is the foundational in NLP. And CAMeL Tools offers a range of utilities to streamline this process. If we start with the transliteration, and we are going to see some examples about it, which is support schemes like Backwalter, Safe Backwalter, and what we have, what's called Habash Saudi Backwalter, which is providing flexibility to work with Arabic in different formats. And then we're discussing the orthographic normalization. And this handles tasks like removing the diacritics, normalizing different forms of the same letter, and also eliminating unnecessary characters. Okay. And these tools ensure consistent and clean input for downstream Arabic NLP tasks. Okay. So we are going to see all these tools. Don't worry, we are going to run them in notebook, Colab notebook, and we're gonna discuss each of them. Uh, let's discuss morphological analysis, which is actually it is crucial for understanding the Arabic structure. Okay, so CAMeL tools includes analysis, generation, and reflection. When it comes to analysis, it identifies all possible readings of a word, including its lemma, gloss, and post tags. Okay. When it comes to generation, it creates inflected word forms based on given features, okay, like the gender, the name, the number, or the tense. When it comes to reflection, which modifies the inflected forms of a word based on a few of a new feature inputs, okay. Uh, okay. So we are going to see some examples about it next videos. So I wanted to make this part for another video to go deeply in their models and what they have for more examples in Arabic. Uh, Now, I would like to discuss the dialect identification and other tasks or applications in this tool. So dialect identification, and I have discussed this in previous videos, we are trying to know the dialects that presents in certain sentence, right? So CAMeL Tools uses a multinomial naive-Bayes classifier, analyzes features like the word, the character engrams, and then applies TF-IDF weighting. And then the model is trained also on Madar corpus, which is a really comprehensive data set that covers 25 Arabic cities, dialect, and MSA. And their system achieved has achieved 67.9% accuracy for short sentences and over 90% for long ones. So making it like very essential tools for tasks like we use it in social media analysis. We also use it in regional language studies. When it comes to name entity recognition, which is identify entities such as names of people, organizations, and also locations. So they are using Arabert, uh, a large pre-trained language model fine-tuned for this task. And it is trained also on this corpus, which is a widely used corpus for Arabic name entity recognition. Their model achieved like 84%, significantly improving even older okay systems. So if you go to the paper and see the benchmarking with other models, you can see this one is outperform. And we lastly discussing the sentiment analysis, which is, as you know, is essential for understanding the public opinion and user behavior. So it's fine-tuned on Arabert, and also they used impaired to classify text as positive, negative, or neutral. So the system is trained on multiple data sets, including let's say this list of data sets, okay, which is of course both like all these data sets includes MSA and dialects. Uh, and it's also outperform baseline models. So in their paper, they have said that CAMeL tools outperforms existing tools like Madamera, Farasa, and also we have the Stanford Core NLP. And for people who are interested in Arabic NLP, go deeply investigating these tools and comparing with CAMeL tools and see the one that fits your application and what you want to achieve. So why this is like outperforming, because maybe it is for different advantages that they have discussed in the paper, like Python-based, user-friendly APIs, the flexible design they have, and it is specifically for Arabic. So yes, as I have mentioned, these tools are used for different wide range of applications like machine translation, social media analysis, and also for digital humanities research. Uh, so, and also, of course, this is the potential users and everyone who are involved or wants to learn more about Arabic. So that's it for the presentation. And let's jump on quickly to see some of these tools specifically for pre-processing. Okay. So here are some steps you can do just to download everything you need from CAMeL Tools. I have done this previously. So CAMeL Tools provide, like as I said, pre-processing utilities. We can use in cleaning, preparing Arabic text, and more. So if we start with this simple transliteration tasks, which is, as I have said, is used to translate each Arabic character to or from a single non-Arabic character, okay? And it's do the mapping. So, as I have said, we have many schemes that are built on, and we have one specifically for this CAMeL tools. So if we see this, which is I went to the library, we can import this from the CAMeL Tools utilities, and we can uh, see how we can do the transliteration here. So yeah, simply here we can see now the non-Arabic character mapping for this sentence. Okay, and car mapper, which is used here, it is very flexible component that can be used for many other types of text transformations. Okay, so this is one of the advantages of using this in this task. And also we have the unique Unicode normalization, and this is important when discussing for Arabic because this is one of the challenges that when it comes to Arabic or dealing with the characters of Arabic. So if you see this character, okay, it can be represented. Let me make it more clear for you. Yeah, like this. You can see it like in different formats, right? Because it depends on their position or where it appears in our world. So for all these forms, we would call this letter to a form, uh, to a specific form, I mean, and use this Unicode characters, which is a composition of multi characters, and in some cases can compromise entire phrases, right? So when we give like this sentence, and we ask to for doing this Unicode normalization, we can see the right or the form, what we call it, the conical form of this sentence. Okay. Yeah, and they, of course, this is represent like extreme example uh, to find the Unicode normalize. When it's come to orthographic normalization, and it is common for Arabic speakers because they use shortcuts, okay? So when typing Arabic text, and this is maybe happen to all other languages, but let's see the challenge here, okay? So the different variation of alif, you can see many variations, especially in Al Hamza. So it comes like in different positions, and simply people writing it like this. Okay, so some of this of these substitutions can just be the result of typos, right? So the presence of these variations can cause data sparsity and are also like it's usually normalized to a single form. So this is the idea of orthographic normalization, which is a process that converts the letter variants or visually similar letters into a single form. So if I wrote this sentence, so I print it here, then I will do like normalize alif, okay, normalize alif. So instead of these different forms, I will go to a single form, as you can see here. Okay, what about this letter? And alif maqsura, we call it in Arabic, or it might be yeah. Okay, so when we normalize it, it comes in that form. Okay, and even for this, which we call it ta marbuta or ha. So when we normalize it, it comes in that form. Great. So yeah, this is the different forms that we can see when we are dealing with orthographic normalization. And even we can remove the tashkil or the diacritics of a sentence by using this. So it simply comes like this. Also, for the word tokenization, we can see how we can split a sentence into words, okay? So this can be split as 4 tokens, as you can see here, okay? And we are using simply sentence.split. So it's provide like split method. We have like the symbol word tokenize, and let's see what's the difference. To split by white space and separate punctuations, we currently provide the utility functions which is called symbol word tokenize. So I think now you can see the difference when it comes here and here. So yeah, we consider the question mark here as a separate token, not as here when using the split. And sorry, I have said like this is the function they use. No, this is the symbols. This is what we used in Python, but this is when it comes to CAMeL tools and the difference between this and this. So yeah, great. That was everything. Yeah, we can also. I want to make this in another video to discuss more about the morphology, so we can see the analysis, the generation, and also the reflection, as I have described before. So this is in general what I wanted to represent here, and I hope you find this helpful for you. And see you next video. Thank you.